Alright, so let's continue talking about ratios of similar figures. So in this I have two triangles, they are similar, and we have to find two different measures on these. So when we did this earlier, I said you can make a ratio out of the same triangle or out of different triangles. So here I can see I have the bottom leg of both of those triangles. So I'm going to make a ratio out of those, because I can use that to solve for both of my missing values. So I have 3 out of 15 equals, and we'll solve for a first. So we're going to do 4 over a. So it's small to big on the first ratio and small to big on the second. So I'm going to do 4 times 15 equals 60. 3 times a equals 3a. Divide by 3. And a equals 20. Now let's solve for the b. And again, I start with that original ratio I created. 3 out of 15 equals b over 25. So I do 3 times 25 is 75. And 15 times b is 15b. Then divide by 15. And 75 divided by 15 is 5. So b equals 5. So when you're doing those, look for a ratio that you can use for both of the variables that you need to solve. Alright, so let's talk a little bit about dilation. And dilation is just a change in size. So you can have a dilation that's an enlargement, or you can have a dilation that is a reduction. Alright, so for us to have a dilation that's an enlargement, we need a scale factor that is greater than 1. And to have a reduction, we need a scale factor that is less than 1. Now a dilation can't have a scale factor of 0, and it can't have a negative scale factor. So it either has to get bigger or smaller, and the way it does that is either by being greater than 1 or less than 1. So let's look at a couple. Alright, so now I got two rectangles, A and B, and the side lengths are 20 and 10 on A and 12 and 6 on B. So I need to find the scale factor. So what you do is set up a ratio. If I'm going from A to B, it obviously got smaller, so it's a reduction. So you make a ratio out of the side. So you can do 12 out of 20 and reduce that. You can divide both those by 4 and get 3/5. So the scale factor there is 3/5. If you were to use the sides of 6 and 10, you can divide both those by 2, and you still get a scale factor of 3/5. So your scale factor there for that reduction is 3/5, and 3/5 is less than 1, so we know is a reduction. But I also want you to see what happens to the area. So the area of angle, or the rectangle A, is 20 times 10. So that area is 200. The area of B is 6 times 12, which equals 72. So if we make a ratio out of that, you'd get 72 over 200. And we need to reduce that. Alright, so to reduce that, we can divide both those numbers by 8. So 72 divided by 8 is 9. And 200 divided by 8 is 25. I want you to pay attention to how this compares to our original ratio of 3 to 5? Well, area is squared because it's a measure of square units. So to find the area squared, you just square the ratio. So if we took that 3 over 5 and we square it, we can get the ratio of those two figures squared. So 3 squared is 9 and 5 squared is 25. So anytime you're going from a one-dimensional to a two-dimensional shape with dilation, you need to square the ratio.